Okay, we're going to look at 6.1, different forms of linear equations, and we're actually going to do this over 2 days. There's 3 different forms of linear equations. We'll do 2 of them today, and then we'll do the third one next day. So the first form of a linear equation is called standard form. It's also called general form sometimes, but we'll call it standard form. And that form of line is this: ax plus by equals c. And a couple things about this. We'd like, as much as possible, your goal, and I think it's always attainable, is to make sure that the A is a number, and you want A to be greater than or equal to 0. You don't want it to be negative, in other words. And then the other thing is that A and B and C are all integers. Although I guess to be more specific, B and C are integers because they can be negative. A is a whole number because it's going to be 0 or higher. Alright, so that could be, I'll just write a few of them here. It could be something like 4x plus 2y equals 8, or x minus 3y equals negative 7, or 9x plus 12y equals 32. Do you see in all these cases, the number in front of the x, it's called the coefficient in front of the x, it's always positive, 4, 1, and 9. And then all the numbers, 4, 2, 8, 1, negative 3, negative 7, 9, 12, 30, they're all integers. There's no fractions, there's no decimals. Okay, that's the goal of standard form. So the first thing we're going to do here is we're going to switch some equations into standard form. This one's not quite in standard form, right? We want to end up with ax plus by equals c. C is the constant. It's the number all by itself. So one way you could do this is by moving the positive 8 over to get the c value. But if you look, the first thing I do when I try to switch these is I look at the x and I look at the coefficient. See how it's negative 2? Well, remember, we want that a value, in this case negative 2, we want that actually to be positive. So what could we do with the negative 2x to make it positive? We can move it to the other side, right? If we add 2x to both sides, then if we add 2x on this side, negative 2x plus 2x is 0, and if we add 2x on this side, suddenly we have positive 2x. That's one way to think of it. The other way you could think of it, some of you learned solving equations this way, is if you take the whole negative 2x and move it to the other side, it then changes its sign, so it'll be positive 2x. So that is probably a good thing to do. Let's move the negative 2x over to the other side. It becomes 2x. Now look, on the same side as the x, we also want the y, so we better also move the 6y to the other side. What's the 6y going to become when it moves to the other side? It's going to become negative 6y. It has to become the opposite. And what's left on the left-hand side is 8. So there you go. We're really done, aren't we? The only thing we've done is we've written the ax plus by on the right and the c on the left. Doesn't really matter, but if you want, I can rewrite it. We have 2x minus 6y equals 8. That's our answer. Okay, this one. Now we have fractions. This will happen a lot. You have fractions. You want to get rid of the fractions. Here's how you get rid of the fractions. You look at the denominators and you find the lowest common denominator. So the denominators here are 5. That's it. That's the only denominator. So lowest common denominator 5 is 5. What you do is you multiply every term by 5. So you're going to multiply this by 5, you're going to multiply this by 5, and you're going to multiply this by 5. Now, why are you doing that? Because that's always going to get rid of the fractions. You'll have no more fractions after this step. How come? Because if you look right here, you have a 5 on top and a 5 on the bottom. Those cancel. You're not doing 5 times 2 and 5 times 5. Remember, when I multiply by 5, it's the same as 5 over 1. And you can cancel here. It's my grade 8, so you can ninja slice. So these are gone. So all you're left with here is 2x. Plus 5 times 3y is 15y. 5 times 1 is 5. Is that in the correct form? Yeah, it is. 2x, my 2 is positive, plus 15y equals 5. It's exactly in this form. Okay, here's another one where we have to get rid of fractions, and we have a whole bunch of fractions. We have 3 denominators, 3, 2, and 6. What's the lowest common denominator of 3, 2, and 6? The lowest common denominator is 6. So you need to multiply everything by 6. The first term by 6, the second term by 6, the third term by 6. Okay, why are we doing that? Because that'll get rid of all the fractions. So the first thing you could do is you could cancel. You could go the 6 and the 3 can cancel. You can divide them both by 3. So 3 divided by 3 is 1. That's great. We have a 1 on the bottom, so we don't need to write it. And 6 divided by 3 is 2. So we just have 2 on top. Let's do all this first. Next one, 6 and 2. We can cancel those ones. 2 divided by 2 is 1, and 6 divided by 2 is 3. And here, 6 and 6, we can divide them both by 6 and get 1 on the bottom and just 1 on the top. Great. Now we can do our multiplying. 2 times negative 1x is negative 2x. 3 times 1y is positive 3y. And 1 times 5 is 5. Is this in the correct form? No, it's not. We do not want this first one to be negative. So what do I need to do? I need to move these two on the left over to the right so their signs change, and this one over the right over to the left. So this negative 2x moves to the other side and becomes 2x. That's what we want. We want the one in front of the x to be positive. The positive 3y moves over and becomes negative 3y. And we'll move the positive 5 to the other side, it becomes negative 5. There you go, we're done. If you want, you can rewrite it with the 2x minus 3y on the left and the negative 5 on the right. There you go, those are standard form. Now we're going to graph some things in standard form. Guess what? You did this before. We didn't call it standard form before, but when you were graphing linear equations, you graph stuff like this. So this is basically the ones where you're going to look for intercepts. So you're going to make a very small table. And let's find the y-intercept of this first equation right here. Well, if we're looking for the y-intercept, that's where it crosses this y-axis here. What do you know about the x value? Every point on this axis here has an x value of 0. So let's figure out what that equals. If I put 0 in here, I get 5 times 0 is 0. So that's, you don't have to look at that. All you're left with is 4 times what equals negative 20. Oh, the answer is negative 5. There you go. We know already that where this graph crosses the y-axis is at 0, negative 5, right here. Okay, now let's find the x-intercept. If we're looking for the x-intercept, it's where it crosses the x-axis, this line right here. What do you know about every point on that x-axis? What's the y value of every point on that? 0. So I put y into the 0 this time. If I put 0 in there, 4 times 0 is 0, this is gone. So all I have to do is 5 times what equals negative 20. 5 times negative 4 is negative 20. So my x-intercept is negative 4. There, it's good enough. I have 2 points. I know often we like to do 3, but who cares? We'll just go with 2 this time. So I'm going to draw a line, and I'll make it red so it matches this first equation. So we've got an arrow on the end, and let me just highlight this red so we're clear that this equation matches that line. Okay, done. Let's do another one. I'll do this one a different color. I'll use blue for this one. So let me highlight it blue and use blue. Although it's a different type of blue, but oh well. Okay, so 3x minus 2y equals 9. Going to make my little table, and I'm going to find the intercepts. If I'm looking for the y-intercept, that means that the x value is 0. So I put 0 in here. 3 times 0 is 0. I don't need to look at this anymore. Negative 2 times what equals 9? Well, you could divide both sides by negative 2 if you're not sure. You're going to get negative 4.5. So we know that, whoa, it's kind of close to the other one, but we know that it goes through at negative 4.5. It is okay if it's not perfect pretty points, like that. And if we're looking for, so let me erase this. That's too bad. If we are looking for the x-intercept, that's where the y value is 0. So if I put 0 in here, that means this is all gone. 3 times what is 9? 3 times 3. So the x-intercept is 3. And I'll draw a line there, and I'll make it blue this time. Put some arrows on the end, and there you go. We've done them both on the same graph. Can hardly see it anymore, but there you go, it matches. Yay, I like my colors. Alright, so that's graphing standard form, and let's move on. Now, I think the most important form is slope-intercept form. This is the one that I would say is the most useful, easiest to graph, etc. So what does slope-intercept form look like? It looks like y equals mx plus b. We'll talk about that more in just a second. I just want to show you something first. If I wrote something in slope-intercept form, it could be something like y equals 2/3 x plus 4. Now let's graph that, but let's graph it the way you've done in the past, and I'll show you how this is actually a really easy form to graph once you understand a few things. So let's graph this. Let's put some easy numbers in here. Let's put, like, for example, how about x is 0? That makes it really easy, doesn't it? Because 2/3 times 0 is 0, plus 4 is 4. So one point is at 0, 4, right there. Let's get 2 more points. How about if we multiply by 3? That works out nice, because 2/3 times 3, I'll just write that down here, 2/3 times 3, or 3 over 1, these cancel, and you're just left with 2 over 1, or 2. So you get 2 plus 4, which is 6. So 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. And let's do one more. How about multiply by 6? Because 2/3 times 6, or 6 over 1, you could cancel the 3 and 6, divide them both by 3, and you're left with just 2 up here. 2 times 2 is 4, so 4 plus 4 is 8. Hopefully you understand what I'm doing here. So 2, 4, 6, 8 is another point. 2, 4, 6. Great, and it lines up in a line, so we've definitely done this correctly. There's our graph. So two things I want to look at here is what's the y-intercept of this graph and what's the slope of this graph. Alright, well the y-intercept is right here, and the y-intercept is 0, 1, 2, 3, 4. The slope, you can pick any 2 points. I'll pick these 2 right here and do my triangle. Rise is 2, run is 1, 2, 3. So the slope is 2 over 3, and it's positive. Now, if you look back here, do you see how I could get those numbers really quickly? This number right here is the slope. This number right here is the y-intercept, and this will always be the case when you have things in slope-intercept form, that the m value, remember it was y equals mx plus b, the m value is always the slope, and the b value is always the y-intercept. This is a great thing. So again, this m right here is always going to be the slope, and this b value right here is the y-intercept, or if you want, you can say the y-intercept equals 0, b. Okay, so for example, if we had something like this, y equals 1/2 x minus 7. What's the slope in this case? Well, the slope is the m value that's right in front of the x, so the slope is 1/2. What's the y-intercept? The y-intercept is the number at the end here. It's not 7, it's -7. Okay, you have to take the sign with it. If this was a +7 here, it would be +7. If it's a -7, it's -7. Alright, so we're going to switch some of these things into slope-intercept form. To get into slope-intercept form, we need this y all by itself. So let's try to isolate the y. The first thing I'm going to do is I'm going to move the 5x to the other side. So when 5x moves to the other side, it's going to become -5x. Notice that I'll put the -5x before the 14, just so it kind of matches here. We have our x before the constant. The constant's 14, so I still have plus 14. Now, this is 2 times y. We have to do the opposite of timesing, which is dividing. But be careful here. You're going to divide this side by 2, of course, to get rid of it. And you're going to divide, there's 2 ways you could do it. You could say I'm going to divide this whole side by 2. But I think what you'll find easier is, and this is exactly equal to what I just showed you, you could also divide this by 2 and this by 2. That's the same as dividing the whole thing by 2. And this, I think, will make it a little bit easier for you to write your final answer. These ones cancel. You're left with y equals, we like keeping the slope as a fraction, so it's just -5 over 2x, and 14 divided by 2 is 7. There you go, we're done. What's the slope? The slope is -5 over 2. What's the y-intercept? The y-intercept is 7. Great. Let's do another one. We want to get the y by itself, but we also want y to be positive. Since y is negative here, -6, why don't we just move that over to the other side? So we're left on this side with x plus 30, and we're going to move to the other side, the -6y, it becomes 6y. Now, we want just y. We don't want 6 times y, we just want y. So what do we have to do? We divide this by 6, and we divide this whole side by 6, or I think a faster way to show it is divide them both by 6 like that. Okay, this cancels, and you're just left with y. I'm going to write it first. Y equals, and on the other side, I have x over 6. What number's up top here in front of the x? A 1. So it's like 1 over 6x. I mean, you could write it x over 6, but I think it's easier to see what the slope is when I write it like this. And 30 divided by 6 is 5. So my slope is 1 over 6, and my y-intercept is 5. Oh, for y-intercept, you could also, instead of just saying the y-intercept is 7, you could have said it goes through the point 0, 7. And same here, the y-intercept's 5, or you could say it goes to the point 0, 5. Either way is fine. Last one, we want y to be positive, so I better move this negative 4y to the other side. And I got to isolate that y, so why don't I move the 7 to this side, to the left? So the 7 is going to become negative 7, and the negative 4y is going to become 4y. Now I want that y by itself. I got to divide by 4, and I'll divide these both by 4. Okay, these cancel, so I'm left with y equals 16 over 4 is the same as just 4, so 4x, minus 7 over 4. Ew, ugly question, because you have a horrible y-intercept. The slope is 4, the y-intercept is negative, because there's a negative sign there, right? Negative 7 over 4. Or you could say the y-intercept is 0, and then negative 7 over 4. I usually won't ask you to graph stuff like that. I mean, I could, but it makes it a little bit difficult because you're dealing with fractions and stuff like that. Okay, there is another way. You know how I've kind of rearranged things and everything? Like to go from standard, like we did here, this is a standard form equation, into to find the slope and the y-intercept. There is another way to do it. I'm not a huge fan, but some people like memorizing formulas. I don't, so I don't memorize this. I always have to look it up every year. But there is another way to do it, and actually we could figure it out ourselves. Let's do it that way. Let's figure it out ourselves. So if we started in standard form, ax plus by equals c, and we wanted to turn it into slope-intercept form, we have to isolate this y. So what's the first thing you'd have to do? You'd have to move this ax over. So you'd still have by here. The ax would move over and become negative ax, and you still have a plus c. Now we want the y by itself, so we need to divide by b and divide both of these by b as well. So those cancel, the b's, you're left with y equals negative a over b x plus c over b. Why does that help us? Because now we can say that the slope is the number right in front of the x. Well, it's not a number in this case, it's negative a over b. That will always give you the slope. If it's in standard form and you want to get the slope really quickly, you can do negative a over b. What's the y-intercept? It's c over b. If you have it in standard form and you want the y-intercept, just do c over b. Let me prove that to you by using this equation right here, which is in standard form. If I wanted to know what the slope is, I could just use negative a over b. What's a? A is 5, so it's negative 5 over b, which is 2. Negative 5 over 2. What do we find the slope is? Negative 5 over 2. Perfect. If I wanted to get the y-intercept, you could just do c over b. What's c? C is 14. What's b? B is 2. 14 over 2 is 7. Is that what we got? Yeah, it is. So it works very nicely. The problem is you have to memorize these two formulas, and I always forget them. But it's easy to figure them out just by doing this. Or you don't have to do this at all. You could just do what we did here and rearrange everything. Okay, we're going to graph these. Graphing is the real beauty of slope-intercept form because it's so fast. What you're going to do is you're going to start with the y-intercept. So in this question right here, we have a y-intercept of 4. So y-intercept of 4, right there. And then we have a slope of negative 2 over 3. Remember, slope is rise and run. That says rise, not rice. And it's negative, so I'm going to rise negative 2. That means go down 2, and I'm going to run 3. 1, 2, 3. Maybe I'll do it again. Rise negative 2, run 3. 1, 2, 3. Should I do it once more? 1, 2, 1, 2, 3. And they all line up. Great, I'm finished. You didn't have to do it 4 times. You could have just done it twice or 3 times or whatever you want. So I'm ready to draw my line now. I'll make it red. Okay, let's do the next one. We'll do it blue. Y equals 2x minus 8. So here's our y-intercept. The y-intercept is negative 8, right? So we go down to negative 8 and we put a point. Now what's the slope? The slope is 2. But we like our slopes to be fractions, so let's make it 2 over 1. We're going to rise 2 and run 1. So from the y-intercept, we rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Do it as many times as you want. Okay, I will now draw my line. I'll make it blue. Okay, and I'll highlight that. Whoa, terrible job, to make it match. So there's my graph for that one. Okay, moving on. Y equals 3. Well, that's a strange one, isn't it? Let's do it purple or something. Y equals 3. So slope and y-intercept in this case. Well, the slope's always in front of the x. There is no x here. So how many x's must we have? we have no x's. The slope is 0, which means the y-intercept is 3. So y-intercept is 3, 1, 2, 3, and the slope is 0. Remember what a 0 slope looks like? A 0 slope is just a horizontal line. And you should remember this from before. We talked about this before. If you have an equation that just says y equals 3, it's always just going to be a horizontal line. This is y. Y-intercept's 3 and the slope is 0. So I'll draw that line. Highlight that one purple, and the last one, why don't we go with yellow on this one? Okay, now it says graph the following slope-intercept form equations. This one here in yellow is not in slope-intercept form, so we need to either change it into slope-intercept form, or we need to use our little formula that we did here. By the way, notice how using our table, like we often do with standard form, like this isn't standard form, right? But if we use our table where we find out the intercepts, it won't work. I'll show you why. Because, for example, if you want to get the x-intercept, you make 0 for y. And if you put 0 in here, now what you're left with is 3 times something, which is 0, and that's 0. If you want to get the y-intercept, you put 0 in for x. And if you put 0 in here, 3 times 0 is 0. Negative 2 times y equals 0. It's also 0. All you have is 1 point, and you can't draw a line with 1 point. All you know so far is this point right here. So that's not good enough. So this is a case where you have to either switch it into slope-intercept or use our formula. I imagine you want to use the formula, don't you? Okay, let's do it. So slope equals negative a over b. Well, that's negative 3 over negative 2. b is negative 2. And negative 3 over negative 2 is the same as 3 over 2. Okay, y-intercept is equal to c over b. c is 0 and b is negative 2. 0 over negative 2 is just 0. So we have a y-intercept of 0, and yes, we already put that in there, so that's good. And then we have a slope of 3 over 2. And then we're going up 3, 1, 2, 3 over 2. Up 3, 1, 2, 3 over 2. Up 3 over 2. That's good. Now I can draw the line. And there you go, highlighted that green for you. There's your 4 lines on the same graph. I know it's a little bit complicated, but hopefully you get the idea. Why not? I'll just show you how you didn't actually need to use the equations here, the formulas. You could have switched this into a slope-intercept form. How do we do that? We want to get in y equals mx plus b. We want to get the y by itself, and we want y to be positive. So let's move the negative 2y to the other side. So that would give you 3x equals negative 2y to the other side becomes 2y. And then we want to get the y by itself, so I need to divide by 2 and divide by 2. That's gone. So what I'm left with is y equals 3 over 2x. Okay, well there's my slope, 3 over 2. And what's my y-intercept? There's no number out here. Well, that means it's like plus 0, so the y-intercept is 0. So you'd put a dot at 0, just like we did, and then your slope is 3 over 2, up 3 over 2, up 3 over 2. I do it that way because I just don't like memorizing this formula, but you can memorize the formula and do it that way as well. Okay, there you go. That's 2 methods, standard form and slope-intercept. We'll learn the third form of a linear equation next day. Good luck.